Hi, in this video, we're going to take a look at how to summarize IPv4 networks and create an IPv4 summary route. Okay, so summarizing routes. Smaller routing tables are better than larger routing tables because when you have less things have to look up, or a smaller, in this case, a phone book or something, if you have a smaller number of pages you got to look up, you're going to find the information faster. Okay, so smaller routing tables means fewer routes to search. If we can use one static route instead of multiple static routes, size of our routing table will be reduced. So it's just much better. We'll see this is the same also for dynamic routing as well. So the same process for summarizing routes, whether it's IPv4 or IPv6, similar process, applies to both static routing and dynamic routing. But let's take a look. So here we have R1, and we could configure 4 separate static routes for all 4 of these networks, or we could do one summary route since it looks like they have some bits in common, leftmost bits, at least the 172s. Okay, so how do we do this? All right, it's really easy. 3 simple steps. Okay, so in IPv4 here, we're just going to write out everything in binary. Now, actually, the 172 part, which is this first octet here, you could probably just write out 172 since we know all of those bits match. But really, starting with the decimal part of the address that doesn't match is where we're going to want to write out everything in binary. Okay, next, step 2. Just find the column where there's no longer a match. So of course, these first 8 columns match. There's a match, 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 match. These 4 ones match, and we have 0, 0, 1, 1. Oh, no match. So count the number of columns that match. We have 14 bits. Make there's our prefix length, our subnet mask. It's going to be for our summary route. It's going to be a /14. What is that? That's a 255. 252.00. So we've already figured out the prefix length. Next step, it's even easier. We just take those matching bits, in this case, those 14 matching bits, and put all zeros at the end. And there's our prefix, our network address for our summary route, 172.20.00. So here's the summary address. And here's the prefix or subnet mask. We've done it. We've summarized it. Now what we can do is just apply that to our static route. And this will apply to all 4 of those networks. Now it is possible that this summary route may also apply to some other subnets which are not part of this. We'll talk about that here in just a moment. All right, so here it's showing a show IP route static. So this is if we had, in another example on R3, we're showing 3 routes here to 3 different networks. I could take these 3 networks. Okay, step 1, what's step 1? Write them out in binary. Okay. What's step 2? Find the matching bits. Okay. We have 22 matching bits. The 23rd bit doesn't match all the way through. So our prefix length is going to be a /22. Okay. Or 255, 255, 252.0. Our network address is going to be the matching bits followed by all zeros. 172.16.00, and here's our subnet mask. Okay. So we just remove those static routes we no longer are using. Always remove static routes that are no longer needed or being used, okay? Because you can create problems if you don't. And now we're going to add the one summary static route. Okay. And our routing table now has 1 route in it instead of 3. Okay, I had mentioned that it's possible that you might have both two routes. You could have, in this case, let's take a look. R1 says, I have both a more specific route and a summary route. So here it says, to reach the 172.16.10.0/24 network, this network specifically, I'm going through R2. But what if it wants to reach everything else? And here's the static route for that. What if it wants to reach everything else in the 172.16.00/16 network through R3? Well, you can create a summary route for all the networks in this network, once all the subnets in 172.16.1.0, 172.16.2.0, 3.0, whatever that might be. So we might have here the 1.0, let's put a dot there, 2.0, and all the other 172.16s, except 172.16.10 is over here. Okay, so we have a static route for, this could be thought of as a summary static route for all the different subnets here. And we have just a specific route for this one subnet here. Not a problem, because what will happen is when a packet comes in, it will look for the longest bit match. If it can match 24 bits, so this first 24 bits, 172.16.10 dot whatever, okay, if that's the first 24 bits of the destination IPv4 address of the packet, then it's going to send the packets this way. Even though it also matches 16 bits here. Here it's going to match 24 bits because we have the mask. Here it's going to match 16 bits because we have this subnet mask. This is a longer match, so it's going to use that path if it matches all 24. Otherwise, if only 16 bits match, then it will use this path. Okay, so you can have both a more specific route and a summary route. It's not a problem if this summary route may also include in its summary this more specific address that's somewhere else, as long as the router has a path to the more specific along with the summary. Okay. All right, hope that made sense. And that will conclude our talk on summarizing IPv4 networks.